So lecture number 9, actually in this lecture we are going to cover section 4.11 and 4.12 from your textbook. Let me remind you that we studied in the previous lectures how to solve first order linear differential equation, or it isn't necessary to be linear. What I need to say now, it's first order. So all the lectures and all the differential equations which we studied in the previous lecture, only first order. So the separable was first order, the first order linear, also the exact, and the homogeneous one, and the Bernoulli also. All those equations were first order. That means I have only first derivative or one prime. In today's lecture, we are going to learn how to solve higher order differential equation. What I mean by higher order differential equation, maybe I have second derivative, third derivative, fourth derivative, okay, or more than this. So in today's lecture, the second order differential equation can be solved or higher than second order differential equation, okay? Here are the objectives of our lecture, and here motivating example. So now I need you to guess two solutions of this differential equation. By guessing, by the way, because it is second order, so we can't solve it using all the previous techniques. All the previous techniques for only first order differential equation, one prime. Now I have two primes. Before I start studying the techniques which will help me to find the solution of this differential equation, let me guess one solution at least. Can anyone of you guess one solution? A function such that if I plug in this equation, I will get an identity. Yes, Ahmed.
We will take the 16y to the right side.
Okay, so just 1 minute. So you need, yeah, just a minute. So here y double prime. By the way, my question is to guess, but you need to solve. No problem. Let me write what you say. Equal negative 16y. Okay. So now, what do you want me to do?
I'll say that y dash is equal to negative 8y squared and y.
So just a minute. So you integrate the both side with respect to what? I think you said I'm going to integrate both sides with respect to x. Yeah. So the integral of y double prime. So here the integral with respect to x, and here the integral with respect to x. You are right. The integral of y double prime with respect to x, it's y prime, because I'm going to cancel one derivative with the integration. Equal negative 16
yx.
Yx. Yes. Yx. I agree. Plus c. I agree. Please don't write anything. Anyone of you, don't write anything. Yes. Continue. Also, you need me to integrate both sides now.
Yeah.
Okay. But unfortunately, after look now. So the integral here y equal. How to integrate this product with respect to x? How to integrate this don't forget that if I wrote I know that you need me to write y x squared divided 2, am I right, plus cx plus c1. Am I right, Ahmed? You want me to write like this to consider y as a constant? Actually the y, it is a function of x, so its integration, this product isn't this one. So I'm really sorry, because you can't do this integral unless if you separate all y together and all y together, all x together and all y together. I'm sorry. So now I can do that because my equation of second order. And by the way, now I need you to guess. Yes.
You can say that it's sine for x or something.
Yeah. Sine for x. Let me check. So David suggests, great save it, David. David suggests, let us check if the function y equal sine for x, it is a solution for this or no. So I'm going to find the first derivative. It is 4 cosine for x. And now I'm going to find the second derivative. Second derivative, because you have cosine, so you have negative. The 4 times 4, it will be 16 sine for x. Let me check. I'm going to plug in here. So negative 16 sine 4x plus 16 my y, it is sine 4x, which David suggests to be 0. Now this one is similar to this, so 0 equals 0. Nice. So I can guess this solution. Yes, great, David. Can anyone guess another solution? Another function such that if I plug in here, I will get an identity.
Doctor, does a constant solution work? Like y equals 0?
Y equal, yes, the y equals 0, we call it a trivial solution. Trivial solution. So this solution, it is a solution for any equation with the right hand side 0. Okay? So I don't need this. I need one isn't 0. The second one, by the way, is very easy also. Can I say it is cosine for x, not sine? Let me check. So y prime, it is negative 4 sine for x. And y double prime, I have the negative here, and the 4 and 4, so it is negative 16 cosine for x. Let me plug in here. So negative 16 cosine for x plus 16, instead of my y now, it is cosine for x equals 0. Now I'm going to cancel out this with this, 0 equals 0. Yes, so I'm right now. This is also second. So I can guess two solutions for this differential equation. Only in this lecture, I need you to guess, because we are going to learn specific technique how to solve this equation. Okay? Now, what I need also you to understand that after finding those two solutions, so by guessing, I can guess this one and this one a solution. Also, now I need you to check the following. After guessing this and this, I need to check if this function also solution for my differential equation. How to check that this function is a solution for my differential equation? How to check a function is solution? How to do that? Speak, please.
Plug it into
Yes, plug in the equation. So I'm going to find y prime. So here my y prime equal derivative of cosine, it is negative, and I have 4, so it's negative 4 c1 cosine for x, sine for x. Plus I have 4 for sine, so it's 4 c2 cosine for x. Am I right here? Now I'm going to find second derivative. Y double prime equal. Now I have this 4 for sine, so it's negative 16 c1 cosine for x, and here the derivative of cosine is negative, and I have here plus, so it's 16 also c2 sine for x. Any question about my derivative? Now I'm going to choose negative 16 to be common factor. So I have c1 cosine for x plus c2 sine for x. Am I right? Notice now the terms inside my bracket, those are my y. So I have negative 16. All those are the same like those are my y. So negative 16y. Now I'm going to plug in my differential equation in star. Maybe let me go to this one star. So I have, instead of y double prime, negative 16y plus 16y equals 0. Yes, so 0 equals 0, satisfied. So also this one is a solution. So starting from now, if you guess two different solutions, you can find another one by finding linear combination between them. What I mean by linear combination, I multiply the first one by a constant and I multiply the second one by a constant, then I add them together. And by the way, notice, now because you have here two primes, so I have in this one two constants. Okay? Any question about checking if the function is a solution for differential equation? No questions, so let me go to the second slide. Now let me introduce the nth order initial value problem for linear differential equations. So notice in today's lecture, all my differential equations are linear, okay, and of nth order. What I mean nth order, maybe I have second derivative, third derivative, fourth derivative, and so on. we studied the initial value problem for first order differential equation, but today maybe for second order, third order, and so on. This is the general form for the initial value problem of linear differential equation of order n. So the highest derivative now is n, as you see here. The highest derivative is n here. Now notice that you have a function of x times derivative of y. Function of x times the derivative of y. So this function, no y. Also here, function of x, no y times the first derivative. Function of x, no y times y. And your right-hand side, it must be a function of x. You can't use it as a function of y. Okay? And I have here like n derivative. My order is n. So the number of initial conditions also must be n. Okay? Now, we expect the following, that the general solution of the above differential equation must involve how many constants, and also those initial conditions, those constants you can, and by the way, I think all of you know, and you did similar to this in your exam, that if I have to solve, if I need to solve initial value problem, after solving the differential equation, I will get some constants. Depending on the given initial condition, I'm going to determine those constants. Also here, determine those constants depending on initial condition. Okay? Now let us answer those questions as the following. But before, let me study the existence and uniqueness for the solution. Yes, we studied the existence and uniqueness of first order differential equation. If you remember, also in your exam, you have one problem of true false to check if the differential equation has a unique solution at a specific initial condition. But now we are going to study the existence and uniqueness for the differential equation of higher order. So you have 2 primes, 3 primes, and so on. This is my initial value problem of nth order. I have nth derivative and I have n initial condition. And I need to study the existence and the uniqueness for the solution of this differential equation. Here the theorem. So this theorem here, 4.11, study the existence and uniqueness of the solution for nth order initial value problem, not first order initial value problem. By the way, I have the proof for this differential equation, and you can read the proof from your textbook. If you have any difficulty, and it isn't included in my exam, so the proof isn't included. Let us read the equation, the theorem now. I have the coefficients, I have those coefficients, a1, a1, and an minus 1 and an minus 1, and a1 here, and a0, the coefficients of y, all of them. And also the dx are continuous. Dx is your right-hand side here. So all of coefficients functions with my right-hand side with no y are continuous. Also, I have another condition. The anx, the coefficients of the highest derivative here, aren't 0. So those are, all of them are continuous, and the coefficients of highest derivative isn't 0. Then I can say at point x0, there is a unique solution for the differential equation in a specific interval. So to check or to find the interval in which your initial value problem has a specific has a specific solution or one solution, you have to check if all those coefficients are continuous and to check when this function isn't 0. Let me explain in one example. So I have here this problem here. Find the largest interval. Okay, I understand the largest interval that include x equals 0. So you need your interval to include the number 0, such that the initial value problem, which is given here, has a unique solution. Yeah, and look here, you have two conditions. You have two conditions. Yes, let me choose maybe the red. Yeah. So now has a unique solution. For me, I understand that I have to check first of all if the gx, the a0x, a1x, and a2x, all of them are continuous. What do you think about those functions? All of them are continuous. So here the solution. All the functions are continuous in R. Am I right? In all R. Yes. Now, second condition, so let me call this is one, and second condition is to find the interval in which the coefficients of the highest derivative isn't zero. So let me choose x squared minus 4 not equal 0. Can anyone help? Not equal 0. Can anyone help how to solve this equation?
X is equal positive or negative 4.
Yeah, so x squared not equal to 4, and that will give me x not equal to positive or negative 2. Now, the interval, so the intervals in which x not equal to the negative 2 and 2, it's from negative infinity into negative 2, or from a negative 2 into 2, or from 2 into infinity. Am I right? 2 and 2 infinity. Now, in one of them, there is a unique solution. Let me say again, in each one of them, there is a unique solution. But he need me to find largest interval that includes 0. So what is the largest interval which include number 0? Where is the largest interval?
من negative 2 to 2.
Negative.
Negative 2 and 2. You are right. So the largest interval from negative 2 into 2. So now I can say the given initial value problem has unique solution in this interval only. Okay? Is it clear? No questions? So let me go now to the new definition of homogeneous linear equation. Before that, can anyone of you remember what I mean by homogeneous equation? If you remember, did we study the homogeneous equation?
When we plug in
Yes.
tx and ty instead of x and y, they
are
are
right.
homogeneous of the same degree.
Yes, great. The word degree is very nice. So mtx and ty equal maybe t to the power alpha mxy. Am I right? So if my function satisfy this identity, I can say my function m is homogeneous of degree alpha. Okay. Notice here homogeneous of degree alpha. But in today, I'm going to speak homogeneous linear. By the way, here M isn't necessary to be linear. But now I'm speaking about homogeneous linear. There is a big difference between homogeneous of degree alpha and homogeneous linear. The homogeneous of degree alpha, which we studied in the previous lectures, only you need to satisfy this condition. And to solve this equation, you need y over x to be u. Okay? So you need this substitution, if you remember. But in today's lecture, or in homogeneous linear, it isn't similar to this at all. So please take care about the homogeneous of degree and the homogeneous linear. And starting from now, I'm going to say homogeneous without the word linear. But if you need to solve using this technique, you have to say homogeneous of degree something. Okay? Let me introduce the definition of homogeneous linear. Now I have this differential equation of nth order, my differential equation order, because the highest derivative n. I can say that this differential equation is homogeneous if the following conditions satisfy. So the right-hand side is 0. Starting from now, if you have higher order differential equation and your right-hand side is 0, so you can say this equation is homogeneous linear. Okay, let me write some examples and you have to decide. X squared y3 primes minus sine x y prime plus 10y minus x equals 0. What do you think about this equation? Is it homogeneous or no?
No,
No. Why it isn't homogeneous?
because g of x equals 0. Or equals x of 0.
Yes. So here I can move this negative x to be here, because my left-hand side, all the terms must multiply by y or its a derivative. So if you have any term with no y, you have to move it. So this equation isn't homogeneous, because I have a term x, which I can move it to be my gx not equal 0. What about of this equation? Let me say y to the fourth derivative minus x squared y double prime plus y prime plus 1 equals 0. What do you think about this equation? Homogeneous or no? What do you think?
No,
No, because you will move number 1 to be negative 1, so it isn't 0. So the homogeneous may be like this one, y double prime plus y equals 0. Yes, this equation is homogeneous because the right-hand side is 0 and no x in my right-hand side. Okay? Or no function isn't multiplied by y or its derivative. Did you get the idea what I mean by the homogeneous linear equation? Now, only I here add that take care about the difference between homogeneous and the homogeneous which we studied in the previous lectures. So, I'm sorry. Yes, I don't need those. Yeah, don't forget that. Now, solution of homogeneous. So, our aim in this lecture and the coming one is to find the solution of homogeneous differential equation. Into the lecture, a brief introduction to get the solution of this one. But before that, I need some mathematical tools to help me to solve this differential equation. First of all, number 6, this equation, it's homogeneous linear equation. Okay, and I need to check how to find its solution. First of all, in this theorem, which we call it superposition principle, okay, and you can find its proof, and if you need, you can read it and ask me if you have any difficulties from the textbook. The proof isn't included in the exam. This theorem said, so I have y1, y2, and so on, yk. All those are solutions of the homogeneous equation. So David guess y2, Islam guess y3, Mahmoud guess y4. Okay, so each one of you guess one solution. Now, can I take linear combination of them? What I mean by linear combination of them, I'm going to multiply the first one by constant plus the second one by constant plus the third one by constant, and so on. So the linear combination between any functions, that means please multiply each one of them by a constant, then add them together. So the superposition principle state as the following: if you have more than one solution for the differential equation, you can get a new solution by multiplying each one by a constant, then add all them together. Okay, so starting from now, if I give you differential equation and I give you two solutions for this differential equation, okay, and I asked you to give me a new one, it's easy. Multiply the first by the constant and the second by the constant, and we call this superposition principle for the homogeneous equation. Okay, is it clear what I mean by superposition principle? No questions. Now I have a question. This is my homogeneous equation, and I have this equation of nth order, so the highest derivative is n, and also I guessed in solutions. I guessed in solutions. Now notice now the number of my solutions is similar, or it is the same like the order of my differential equation. Can I guarantee that the general solution of my differential equation is the linear combination between all of them? So starting from now, maybe I will ask you to guess one solution, okay? But sometimes I need you to find the general solution. What I mean by general solution, your solution which contains some constant, and this one can give me all the other solutions. Okay. Now my question, if I have n solutions, can I consider the linear combination of them is the general solution or no? How to check that? Let us study the following theorem. But before that, could you please write your names? I need you to write your names, please. All of you, please write your names. Let us continue. Actually, to answer my question, which was if I have n solution for nth differential equation or nth order differential equation, can I take a linear combination between them to get a general solution or no? To answer this question, I have to study something we call it linear dependence or linear independence. Dependence or independence. Let us study the following definition. In this definition, I'm going to introduce what I mean by linear dependent or non-linear independent. So I have two different words, dependent and independent. Let me introduce the definition of dependent. If I have n function, okay, and I'm going to multiply each one of them by a constant. So here I have function by my first constant, constant time my first function, and constant time my second function, and so on. And I take them to be 0, okay? If I can find all those, if I can find those C's such that not all of them are 0. So I wrote this equation, and I'm going to find the C's. If one of those C's aren't 0, so the functions are linear dependent. But if I have this equation and I'm trying to find the C's and all the C's are 0, so the functions are linearly dependent. Maybe I said something wrong. Let me repeat it again. If one of those C's aren't 0, so the functions are linearly dependent. Now, if all the C's are 0, so the function are linearly independent. So all C 0, that means independent. One C isn't 0, so they are dependent. Let me give you an example and you'll find it's easy. Very easy, not only easy. But please look to this equivalent definition. Maybe some students prefer to use this. So you have here n function. You have n function here. Those n functions. If you can write one of them as a linear combination of the rest functions, so one of them is equal to number times the first plus number times the second, and so on. At that time, you can say that those functions are dependent. Here are the examples. I have two examples. and I need to check if those functions are linearly independent or no in the interval from negative infinity into infinity. So let us write here in the black slide. Together now we are going to solve the first one of them, or to check the first one, those are linearly dependent or no. Here the first one, I'm so sorry. Yeah. Now, can any one of you, maybe I'm going to choose the equivalent definition. Can any one of you write one of those functions in terms of the rest functions? Look to the functions.
We can
Yes.
write the second function as half times the first function plus half times the third function.
Great. Who is speaking?
أحمد النور.
Ahmed Al-Arabi? Yes,
No,
great. Yeah, great. So your colleague used now the rules of double angle. Do you remember? I'm going to write the second one, Ahmed, okay? Or the second formula, cosine to x, it is 2 cosine squared x minus 1. So I can write one of my functions as a linear combination. Notice now I multiplied the second one here by 2, and I multiplied the first one by -1. So now I'm going to say that those functions are linearly dependent, because I can write one of them in terms of the rest functions. Let me give you another example. So if my functions, if 1x equal maybe 1, my second function, if 2x equal sine squared x, my third function, if 3x, it is, let me call it cosine squared x. What do you think about those functions? Dependent on each other or no?
Yes.
Yes. What is the relation which can given to be on those functions?
Sine square plus cosine square equals 1.
Yes, sine squared plus cosine squared equal 1. So one of my functions is linear combination between the two functions. What I mean by linear combinations, so that means you take your function and multiply it by constant. Where is my constant here? Is 1. Let me go to the third one. Can anyone give me a relation between those three functions? It must be linear. You can't take the division between them. You can't multiply them by each other. You can't take squared of the first one or second one.
Well, can we repeat the last step تاني يا دكتور معلش؟
Number 2.
يعني هي دي اللي هي cosine 2x دي الدبل انجل رول صح كده؟
Just a minute. This is first problem.
Yes.
This is second problem. This is third problem. In the first problem, we found this rule. Do you remember this rule?
Yes.
Yeah. Now, so because I find a rule between my functions, so I said those functions are linearly dependent. Now, second problem, I have 3 functions, 1, 2, 3. Now, it's we call, I'm not sure this identity, we call it what? Do you remember the name of this identity?
لا I don't يا دكتور بس I know it يعني.
Yeah. Actually, in Arabic we call it, but I'm not sure in English. We call it الذهبية. So now, if you can find the relation between your functions, so you will say those functions are dependent, linearly dependent. Okay. Now I'm going to move to question number 3. So any question now, Umar, about number 1 and 2?
لا تمام.
Okay, so those aren't steps. Those are 3 different problems.
يعني احنا we just added اللي هي function 2 to function 3 صح
and we
كده؟
found number 1 and
Yes,
we found
okay.
function number 1. Now, Omar, could you please help me? Can you do something similar to those. So now here I have a rule and here I have a rule. What do you think about number 3? Do you have a rule which contain number 1 and cosine and sine without squared one of them? I need it to be linear of your functions.
I think there is اللي هي sin 2x.
Sine 2x, so let me write, just give me 1 minute. So sine 2x, I'm going to write here, sine 2x equal
2 sin x cosine x.
2 sine x cosine x. I understand.
معرفش بقى ليها علاقة ولا لا.
Just let us check. This is my first function. And this is my second function. But this one isn't my third. So this can't help. Because I need 3 functions, sine, cosine, and 1. And by the way, you can't multiply them by each other. Only linear combination between them. So add, subtract, and multiply each one by a constant. So here the rule it's contain a product. So I don't. This one can't help. But maybe there is another relation which can help. I'm not sure. What do you think, the other students or Umar also? Anyone? Do you have a relation which contain those 3 functions?
مش عارف يا دكتور، أظن مفيش يعني.
Actually, for me, I don't have. So, but now, how to prove that those functions are linearly independent? So, the linearly independent, you will multiply each one of them by a constant and let the answer to be 0. So, multiply the first one by a constant, so it's C1, plus multiply the second one, it's C2 cosine x. Multiply the third one by a constant, so it is C3 sine x. And let your answer to be 0. Now, you have to determine the value of the constants. If all the constants are 0, so you can say that those 3 functions are independent. Now, how to find the value of the constants? Actually, I can find the value of the constants by equating between the coefficients in the left and the coefficients in the right. Now, let me equate between the constants in the left. What is the constant in the left? It is C1. And the constant in the right-hand side is 0. Now, also, equate between the coefficients of cosine in the left, which is C2, equal the coefficients of the cosine in the right, it's 0. Now, let us equate between the coefficients of sine in the left, which is C3, equal the coefficients of sine in the right, it's 0. Now, all my constants are 0, so I can say those functions are linearly independent. So, if all the constants are 0, you can say independent. Any question?
دكتور ممكن نعملها في واحدة من اللي فوق؟
Repeat.
نعملها في واحدة من اللي فوق.
Yes. So let us check if I need to use this technique. I'm sorry. Yes. No problem here. But I need to use another color.
ومش يدي 0 برضه فوق يا دكتور ولا ايه؟
The first one? So let me check. Do you want me to check number 1 or number 2? Number 2, no problem. So I'm going to multiply the first one by a constant C1 plus second C2 times C sine squared x, okay? Plus C3 cosine squared x equals 0. Now I'm going to determine the value of C1 and C2 and C3, okay? I need to determine the value of C1 and C2 and C3. If all of them are zeros, so the functions are independent. But if one of them at least non-zero, so the functions are dependent. Okay? Now for me, I can guess the values of C1 and C2 such that this equation satisfies easily. Let me choose my C1 to be -1 and my C2 to be 1 times sine squared x. And also I'm going to guess C3 to be negative, to be 1 also, cosine squared x equals 0. Now I have a question here. Is it satisfy or no? What do you think? So I found my C1 -1, my C2 1, my C3 1. Let me check if here I have something right or wrong. What do you think about the answer here? Those are what? -1 plus sine squared plus cosine squared. Is it what?
It's not going to be equal to 0, doctor.
Can or can't?
It won't be equal to 0.
It won't be 0. So 0 equals 0. Can 0 or no? What do you think about this?
It will,
Omar?
yes.
It will be 0.
لا
It will be
ازاي
0.
0.
Yes, let me explain. Could you please move number 1 here? So what do you think about this, Omar? Is it right or wrong?
Yes, it's 1.
Okay, so only move number 1 to the left hand side. So I have -1 plus sine squared plus cosine squared equals 0. So those which you attached here equal 0. So 0 equals 0. So it's satisfied. So now my C's, not all of them are 0. Okay? So those functions are dependent because I can find some C's not equal to 0, make my equation satisfied.
طب يا دكتور انا مش فاهم حاجة بقى الصراحة يعني.
دكتور طب افرض الايكويشن complicated اكتر من كده مش
We are
الجسم
going, yes, we are going to learn a new technique now.
يعني هو
You are
حضرتك
right.
اخترت سي ب1 يا دكتور ومرة سي
Yes.
ب0 ليه يعني ايه الفرق؟
Which one? Could you please repeat which
يعني
C1 and
in the second equation you chose C's to be 0.
here.
Huh.
Yeah. Could you please guess some values for C's? Make this equation satisfy?
0.
Yes. Could you please guess another values? Can anyone guess another values for C1, C2, C3 here make the right hand side 0? Or
No.
only, yes. So because now I can't guess unless those, so independent. Okay? Because all of them are 0. Now, look here, I choose my C1 negative, my C2 1, my C3 1, and I get 0 equal. You please find another C's, okay? Another C's, or sorry, let me go back. So I choose my C to be -1 and C2 to be 1 and C3 to be 1. This one satisfy or no? So the values of C, which I guess now, satisfy the equation or no?
Yes يا دكتور دي satisfy.
So you have to say those functions dependent. So if you guess the C's and one of them isn't 0, so please say dependent. If you guess the C and unfortunately all of them are zeros and no one can guess those unless those values, so you have to say those functions are independent. And as Ahmed said, oh professor, to guess, now guessing is easy because I know the relation between sine and cosine squared and so on. But if my functions are complicated, what should I do? We are going to learn specific technique. Without guessing, you can't determine that those functions are dependent or independent. Okay? You have any question or can I move to our technique? What do you think, Omar?
Yes يا دكتور, clear يا دكتور. Yes.
Yeah, so let us go now to our technique now, in which I'm going to determine that the given functions are dependent or independent. Actually, in this technique, or to study this technique, we need to learn something we call it Wronskian determinant, or Wronskian determinant. I think all of you remember how to find the value of determinants, but now let me explain how to build this determinant. So if you have some functions, the number of those functions are n. To build a Roneskin determinant, please write first row to be all your functions. Second row to be the derivatives of your function. Third row to be derivative of second derivative, and so on, and so on. The number of columns is equal to the number of functions. The numbers of rows equal to the number of functions also. So your determinant is squared. Number of rows equal to the number of columns. Now, I'm going to use this Roneskin determinant to decide if my functions are dependent or independent. Okay? Let me give you one example how to find the Roneskin determinant. Then we are going to study the theorem which will help me to decide if my functions are dependent or independent. So he asked me now to find the value of the Roneskin determinant of those functions, one cosine sine. Let us together do it here. So I'm going to find now the Roneskin determinant for this function. Those functions, 1 and sine x and cosine x. So for me, I believe the Roneskin determinant, sorry, it's equal here. First row, my functions. And here it is cosine x. Cosine x. Second row, the derivative of the given functions. So 0, cosine x, negative sine x. Third row, the second derivative, so derivative of 0, 0, derivative of cosine, it's negative sine x, and the derivative of negative sine, it's negative cosine x. Okay, and now we are going to determine or to find or to evaluate this determinant. Can anyone of you remember how to evaluate or to find the value of the determinant? Some rules, do you remember? For those who finished linear algebra course or studying it now, and by the way, from secondary school, you can find
Choose
the value of this. Speak,
choose
yes.
a row or a column and
Yes.
take the entries
Great,
and
Ahmed.
multiply it with
Yeah, right. Yes.
let
Thank you
me
very
solve
much.
this one. Like I can take the first column. So the A 2 1 and the A 3 1 are zeros. So I will take 1 times cosine times negative cosine. So it will be cosine
Great.
squared.
Great.
Minus negative sine times negative sine. So it will be negative
Excellent.
sine squared.
Yeah, excellent. Look, I'm going to repeat what Ahmed said. Ahmed said, Doctor, if I have a determinant like this, I'm going to decide that I need to evaluate this determinant depending on a specific row or a specific column. Ahmed advised us to choose that row or that column which contains some zeros. So he noticed that the first column has 2 zeros, so we are going to find the value of this determinant depending on the first column. Second step, sorry, is to give each number of this column a specific sign. So I'm going to give for number 1 plus, for number 0 minus, for number 0 plus. So always it is plus, minus, plus. And I'm going to do the following. Ahmed suggests to do the following. He said, Doctor, take the first number, which is plus 1 here, and you need to multiply it by a new determinant. This new determinant, you can find its element by eliminating or by omitting the row and column of the number 1. Where is the row of number 1? It's here. I'm going to omit it. Where is the column of number 1? It's here. I'm going to omit it. So now I still have cosine x. I still have cosine x, negative sine x, negative sine x, negative cosine x. Okay, let us continue. Now, I'm going to choose the negative 0. Not going to choose, I'm going to take negative 0. Okay, multiplied by a specific determinant also. How to find the elements of this determinant? Also, I'm going to eliminate or omit the row of number 0 and the column of number 0. So now I have the following elements: sine x, cosine x, negative sine x, negative cosine x. Now the third one, which is plus 0, new determinant also. New determinant. I'm going to eliminate its row and its column. So I have the following. Here you have sine x, cosine x, and cosine x, negative sine x. Now I have a small determinant. To find the value of this small determinant, so equal here, equal number 1 times bracket. The rule of second order determinants is to multiply, just a minute, is to multiply this by this. So it is cosine x times negative cosine x, okay, minus this by that. So minus from mine. So I think there is something wrong here. What do you think? No, nothing wrong. Minus negative sine x, times also negative sine x. Okay, and this is my bracket here and here. Minus the second determinant 0 times anything, don't care. The third one plus 0 times anything, don't care. Let us find the value here. So it's 1 cosine times cosine, it is negative cosine squared x. Here minus, so it's minus sine squared x. And those 0. Now I have minus and minus, I'm going to take them as a common factor. So I have negative 1 open bracket cosine squared plus sine squared. What do you think about this summation inside the bracket? It is inside the bracket
1 يا دكتور 1.
1. So it's negative 1 times 1, which is negative 1. Am I right?
اللي احنا جبناه ده ايه بقى يا دكتور؟ يعني determinant?
The value of the Oroniskian determinant. You are right. But till now, I didn't tell you the secret, how to check if those functions are dependent or no. Okay? Now I learned what I mean by the Oroniskian determinant and how can I find its value. Now, in the coming slide here, the secret. The theorem said, if you have n function, so here I have n function, y1, y2, yn, okay? And I need to check if those are linearly dependent or no. I'm going to find their Oroniskian determinant. If the answer isn't 0, so the function is independent. I would repeat, I will give you 100 functions and I need you to check if those functions are dependent or no. You will find the Oroniskian determinant of them and evaluate it. If you get number not equal 0, so those function independent. Let me go back to our function here. So in the previous example, you get, where is my pen? Yes. So here, in this example, you find the answer not equal 0. So if the value of the Oroniskian not equal 0, so you will say the functions independent. Is it clear now how to check set of functions are dependent or no? I'm going to find their Oroniskian determinant, then if the answer isn't 0, nice, independent function. What do you think now? Is it easier than guessing?
Yes.
What do you think? Yeah, great. Now I have two examples. The first one I did in the previous slide, which is 1 cosine sine, is similar to what we did here, 1 sine cosine. Now, the second one, so number 2 here, the example number 2, you have 3 functions, and you have to check if those functions are dependent or independent functions. You are free. You can write the C's and check if you can guess all C's must be 0, so you will say independent. If one of the C not 0, so those are dependent. Or you can find the Wronskian determinant and check if the value of this Wronskian determinant isn't 0, so you will say those functions are independent. So your homework now, your class homework is to do this and send it to me on WhatsApp as a private message. Okay, check number 2, those functions are dependent or independent. Okay. Now, I'm going to introduce a new concept. We call it fundamental set of solutions. It's a very important title, fundamental set of solutions. Now, here you have, look, here you have y1 solution and y2 solution and yn solution. Professor, you said those are solutions. Solutions of what? Solutions of my differential equation. And we are going to study in this lecture and in the coming one, homogeneous linear equation of n order, of nth order. Okay, so all those functions are n1 and all of them linearly independent and are solutions for homogeneous of nth order. So all of them, I can call them fundamental set. No, Professor, please repeat. What do you mean by fundamental set of solutions? I'm going to say, I have differential equation of nth order. And also I have n solution. My equation is homogeneous and linear and of order n, and I have n solution. Okay. Those solutions, I'm going to call them fundamental set if they are linearly independent. So fundamental set of solutions need your differential equation to be linear homogeneous. The number of solution must be equal to the order of my differential equation. Those solutions must be independent. Is it clear? Okay, great. Do you want me to repeat?
Yeah,
I'm sorry.
yeah.
Repeat. Yes, David. So the fundamental set of solution, I will give you differential equation. And I will give you or ask you to find some solutions. Now, let us consider my differential equation of third order. So my differential equation like this. So y3 primes plus y prime equals 0. Okay, this is my differential equation. And I give you y1 and y2 and y3, 3 solutions. Okay, and I'm asking you, those equations, those solutions can be considered as a fundamental set of solution or no? What should I say to prove that those 3 solutions are fundamental set or no? First of all, you have to check if your equation homogeneous or no. Yes, homogeneous. Linear? Yes, linear. Number of the solutions are similar or the same like the order of my differential equation? Yes. Last thing, you have to check if those are dependent or no. How to check that those are independent or no? How to check?
And we just need Wronskian.
Wronskian determinant, you are right. Only we need the Wronskian determinant. Okay? Now, the existence of this fundamental set. My question, this fundamental set can be exist for any differential equation or no? I'm not going to speak about the solution of the initial value problem. No, I'm speaking now about the fundamental set of solution. The theorem said the following. There exists, so always there exists a fundamental set of solution of homogeneous linear differential equation. Always. No conditions. But the students sometimes need to find this fundamental set. And finding the fundamental set isn't easy, maybe. Now, any question about this slide? Actually, this slide, you need it for all my lectures to the end of the course. So this slide is very important. Finding the general solution for homogeneous differential equation. To find the general solution for the homogeneous differential equation, if you have differential equation of nth order, that means you have n primes, okay? And you need to find the general solution. Okay, now I have y1 solution and y2 solution and so on, and yn solution. Those functions are fundamental set. What I mean fundamental set, that the number of solution equal to the order of differential equation, and those functions are linearly independent. So all those functions are fundamental set. To find the general solution, I'm going to take their linear combination. So let me explain again. I have y3 primes plus y prime plus y equals 0. And I have fundamental set of solutions, y1 and y2 and y3. That means the number of those solutions is exactly like the order of my differential equation. And those solutions are independent. Okay. So those are set of solution. Now, to find the general solution of this differential equation, I'm going to do the following. Y, which is the general solution, C1 times the first, plus C2 times the second, plus C3 times the third. This is the general solution. So you need to check if those are fundamental set or not. Clear? Let me continue now. Maybe you are going to solve one example of this problem here. Just a minute. So the first question in this example, find with the proof the general solution. Yeah, the general solution for this differential equation. Actually, he gave us hint because look, in today you have hint. In the coming lecture, you have specific technique. Okay, so don't worry. Some students prefer to solve the problems depending on a specific technique. But actually, some students also need to understand from where I found this rules. So usually, I try to introduce some motivating examples or some hints to solve the differential equation to let the students understand the theoretical concept of my technique. But in the exam, actually, I need only the steps or the solutions of the differential equations, depending on a specific method. Now, he asked me to guess or to use the function y equal e to the mx as a solution. Now, I have small question. If y equal e to the mx is solution for my differential equation, so how can that help me? So you have function is solution. What can I do? What do you think? If you have a function is a solution for the differential equation, then can I say that this function satisfies the differential equation? Am I right? By the way, look here. He asked me to guess this formula. Now, I don't know the value of m. And you need to determine the value of this m. How to do that? I'm going to plug in my equation. Okay, I have second question for the same problem. Let me read the second question, then we go back, go to black slide to solve it. He need me to solve initial value problem, the same differential equation, but he give me two initial conditions. I'm going to do that in this slide. So here, I need to solve this differential equation by using this hint. So here the solution. He give me y equal e to the mx. I need someone to help me. Maybe let me choose Rahma. Rahma here?
Yes, doctor, I'm here.
Yes, Rahma. So now this function is the solution of my differential equation. I'm going to plug in my differential equation. My differential equation has the first derivative and second derivative. Help me to find the first derivative.
It's m e to the power mx.
Great. And also I need the second derivative.
It's m squared
Great.
e to the power mx.
E to the power mx. Now I'm going to plug in my differential equation. So here in this, I'm going back here. So instead of y double prime, I have m squared e to the mx minus m e to the mx. It is m minus 2 e to the mx equals 0. Don't forget, Rahma, that your m now is to find the value of m. Can you please simplify this equation? How to simplify
And take
this?
e to the power mx as a common factor.
Great, I'm going to do that. So here e to the mx as a common factor. So I have m squared minus m minus 2 equals 0. Then what should I do? What should I do?
Can I take a difference between two squares?
No. What is the difference? What is the difference? What is 2 squared here? I have only m squared. So what do you think?
M minus 2 times m plus 1.
So you factorized the bracket. You are right. So I can do that. But let me do one step before that. Now I have a product here equals 0. If you have a product equals 0, so what that mean? One of them is 0. And by the way, some students, instead of writing those steps, they will divide by e to the mx. Okay, but for me, when I need to divide any equation by any amount, I must check if this amount is 0 or no. What do you think about e to the mx? Can be 0 or no?
No, it cannot be.
It can't be 0. So I can divide my equation with this amount, and this amount isn't 0. So now, great, m squared minus m minus 2 equals 0. This is a quadratic equation. I can solve it using calculator. Some students can solve it using general method, which we call it characteristic method. And also Rahma can solve it using the factorizing technique. Okay, so you are free. And by the way, if I have time, I'm going to re-explain the general method to solve a quadratic equation, which we call it characteristic technique. Yes, Rahma, could you please give me here, what should I write?
M minus 2.
Great.
And, m plus 1.
No. Now, some students find it's difficult to guess those two numbers. Please use your calculator. You are free. Okay. Now, from this, you can find the first m minus 2 equals 0, and the second one, m plus 1 equals 0. So from those, I'm going to find my first m equal 2, and my second m equal negative. Can we find another m? No, I have only those two specific m's. So my two solutions, maybe the first solution of my differential equation, y1, I'm going to plug in my m here. It is e to the 2x. And my second solution, y2, it is e to the negative x. Now you found two different solutions for the differential equation. By the way, don't forget that he asked you to find the general solution. Till now, you found two particular solutions. How to find the general solution? I remember. To find the general solution only, I'm going to take the solutions from the fundamental set and multiply each one of them by a constant and add them together. Now let me check if those two functions build my fundamental set or no. First of all, my differential equation is linear, homogeneous. The number of solutions is similar exactly to the order of my differential equation, and those two functions are linearly independent because I can't find one of them by multiplying the second one by a constant. So those two solutions, let me write here, independent. Okay, so the general solution, let me use another color now. The general solution is y equal c1 times y1 plus c2 times y2. That will give me my y equal c1 e to the 2x plus c2 e to the negative x. This is the general solution. We found the solution of the differential equation, which is the first question. I have second question. So here, first question, and now second question. Let me use the blue now. Second question is asking me to solve initial value problem. And as you did in the exam, to solve the initial, after finding the solution of the differential equation, use the given conditions to determine the value of the constants. So let me use the given initial conditions. Y of 0 equal to, equal 5, I'm sorry. This is my x and this is my 5. My y, so this will give me, let me call this equation star. So in star, I have 5 equal c1 e to the 0 plus c2 also e to the 0. Don't forget e to the 0 is what? Can anyone help?
1.
1. So by the way, also if you forget, you can use your calculator. So I have 5 equal c1 plus c2. Great, c2. This is first equation, which contain two unknowns, c1 and c2. I'm going to find them, but let me use second condition. What is the second condition? It's need y prime. So let us find y prime first. So y prime equal, maybe I'm going to write here y prime equal, it's 2c1 e to the 2x minus c2 the negative x, e to the negative x. Now, so here the second condition, y prime of 0 is equal negative 3. So in equation double star, if I call this one double star, instead of y prime, it's negative 3 equal 2c1 e to the 0 minus c2 e to the 0. So I have the new equation, negative 3 equal 2c1 minus c2. This is the second equation. How to solve this system, those two equations, how to solve them? Any idea?
Equal 2c1 plus 3.
Yes. So you moved from equation number 2, number 3, and C. Yes, and you will plug in number 1. You are right. Great.
Yes.
Another method, please. Add those two equations together.
Yes.
Can I add them together? So if I do those two equations, 5 minus 3 is 2, equal C1 plus 2C1, it's 3C1. And C2 minus C2 is 0. So the C1, it is 2 over 3. I found C1. How to find C2 in equation, maybe in equation number 1? C2 equal, move C1 here. So it will be negative 2 over 3. So I'm going to find the common denominator. So it's 13 over 3. This is the C2. After finding those two constants, plug in your solution. So y equal C1, which is 2 over 3 e to the 2x, plus 13 over 3 e to the negative x. And this is the solution of my initial value problem. Is it clear? So do you have any question? Yeah. So I finished now the lecture. Actually, but only I need to tell you that I finished